All right, hello. Let's get started. My name is Bams Teague, and this is my presentation for our first cybersecurity project. Let's get into it. All right. So I'm calling our client Client X since we weren't provided with a client name. I just wanted to make one to refer to. And for them, we're going to be building a virtual network. Let me get that out of the way. All right, so basically, we're wanting to expand Client X's network without giving them additional hardware. We've been approached by Client X to help expand their business network without additional hardware. They've specified that they don't have space for additional hardware while also desiring a more cost-effective solution. To meet Client X's requirements, we're proposing an installation of a virtual network. This virtual network would provide Client X with a network while avoiding unwanted hardware added to their office space. It is also a more cost-effective solution for the client. To set up said network, we're first going to download a program called VirtualBox, which we'll use to house our new virtual machinery. After this, we will make sure if each of our virtual machines are added to our VirtualBox in order to get them up and running. Following this setup, we will proceed to confirm that our network connectivity amongst the new virtual network is working, troubleshooting any issues we encounter along the way. So here we are showing the proof of our downloaded VirtualBox with the successful uploading of each of our virtual machines for the new network, as well as an extension pack needed for the VirtualBox. And here we're going to start testing the network by getting into our CEO PC virtual machine. We're going to open our Firefox browser and test connectivity by trying to go to seclab.net. As you can see in the picture, it did not work. The website won't load, and eventually the browser throws us this server not found error message. The error message comes with some proposals on possible causes. Double checking our work, we can rule out number one, that there were typing errors in our addressing. Their second suggestion that suggests that it could be network connection issues. This sounds like a probable cause, and it's something we can test for. So we will go ahead and test for this. To do so, we're going to use pinging by pinging the DNS and web servers from the CEO PC to see if we are connected. All right, to do so, we'll start out by opening our terminal application. This is the command line interface of this GUI system. So we will open the applications, system and tools, and then terminal application to get there. This way we can interact with the command line in the CEO PC. To access our DNS server and web servers through a ping, we need to know their IP addresses. So we are going to switch into each of these machines and request the IP address using the IP-adder command in each. Looking at the down at the number 2 result that says ETH0, and next to the INET, you can see in each of them their IP address listed. All right, so to confirm whether or not we have network connection issues, we are going to ping the machines that we just collected IP addresses from our CEO PC. Our ping to the DNS server, as you can see on the left, failed. And our ping to the web server, as you can see on the right, also was a failure. This lets us know our network isn't connecting. To explore the problem even further, we're going to double check on the IP address of the CEO PC itself. Here, when we ask for this information, we can see, looking in this same place we did for the other ones, that this PC has its address at 203.0.113.69, when it should be running on our trusted network's IP address of 192.168.0. Range of 0 to 24. That is the IP address it needs to be on to be able to be recognized by the firewall and our other machines. So we need to get our CEO PC's IP addressing fixed and make it the same as the trusted network so our system can be up and operational. All right, so on to resolving the IP address of the CEO PC. We are going to use our network connections icon in the upper right of the CEO PC taskbar, and click through to our VPN connections and configure our VPN. Here, you're going to want to select AutoETH2 and then edit. That'll bring forward the screen on the upmost layer, which you can see in the image on the right-hand side. Here, you'll want to click the IPv4 settings tab in order to view and make necessary changes to our IP addressing. You can note here on this screen, according to our network outline, our IP address, gateway, and DNS server are all wrong for the CEO PC. And we can fix those all together pretty easily by changing what method we're using. So under method, it's currently selected to manual, and we could go in and manually retype all of the incorrect addressing, but go ahead and switch it to automatic DHCP. This option is going to give us IPs dynamically. When we imported our machines originally, we put them on a setting that was all NAT network adapters, which will allow us to look at all of the available machines that we can connect to. And so the automatic DHCP option we selected will do this for us. Apply the change, entering the proper credentials when asked. All right, so here I display our secondary ping testing to double check whether or not our troubleshooting was successful. As you can see in the first image on the left, we do end up with a success to the DNS server, although it is important to note, I hadn't initially switched or reconnected to the network, AutoETH2, after doing the troubleshooting. So at first, it was still unreachable. So make sure you click back into the AutoETH2 using the network icon up top before running your secondary ping tests. Otherwise, it will still be unreachable. In the middle image, you can see my ping to the web server goes through. It is successful. And then in the furthest right-hand image, you can see we go back to the seclab.net and have no trouble making it to our destination. So our network is now connected and operational. All right, so here I've listed the details for your CEO PC, including the OS version, the IP address, subnet mask, the default gateway address, and the DNS server address. I have the same information listed for you here for your DNS server, as well as your web server. So you have access to all of that information. Now we're going to use your CEO PC and the file transfer protocol to download a file called Social Media Security Policy from your new web server. In the image below, you can see we're logging in as a username Jasper. We are specifying our password. Our login is successful. We check our directory when we see the file we're trying to get. We request a get for the social media security policy. Once the transfer is complete, we close out of FTP, and pulling up here our PC, we do a listing of the files available, and you can see that we have successfully downloaded the social media security policy from the web server. Next, on the web server, we are creating a new user. We have created a user named BAMS, and we have successfully updated their password and logged them in, displayed in the images below. Here as well, we are providing you with a big picture visual of the available ports for your DNS and web server using nmap commands. And then we also wanted to make sure that our trusted network is protected from our untrusted network that has been provided. And you can see our display image at the bottom is just one of the ping tests. We can prove the trusted network is protected from the untrusted network through ping tests back and forth. When you ping the untrusted network from the trusted network, you're provided with results and responses from the untrusted network. If you flip those back around though, and try to use the untrusted network to ping the trusted network, as shown in this picture, you get no results. It is not successful. It is not a two-way street, which shows us that our trusted network is protected from our untrusted network, which is good. But I am spotting some vulnerabilities in the system that we will need to address with client X. We can see using Wireshark here on our trusted network that the file transfer protocol we used to get our file earlier did expose the username and password for the user Jasper. This is a vulnerability that will need to be addressed with the client, but it is one we caught. Thank you so much for your time.